Good morning students. This is virtual class of physics, class 12, and today's topic is electric field intensity due to electric dipole in equatorial position, which is formulated as E equal to 1 upon 4 pi epsilon naught k P upon R cube, where P is electric dipole moment. What is electric dipole moment? To know the electric dipole moment, we have to know what is electric dipole. You know that electric dipole is the pair of two equal and opposite charges. Suppose that minus q and plus q, and they are separated at a small distance, at a small vector distance, which is directed towards negative charge, towards positive charge, from negative charge to positive charge, and this quantity is known as electric dipole moment. The amount of electric dipole moment, magnitude of electric dipole moment, is defined as the magnitude of either positive or negative charge multiplied by distance between the charges. Suppose that distance between these two charges is 2L. What is the reason to assume this distance as 2L? Because if we want to break into two equal parts, then 2L can be broken into two equal parts. 2L can be broken in terms of L plus L. So these distances will be in whole part, not fraction. So we assume the distance between two charges as 2L. Then product of amount of one of the charge of electric dipole and distance between the charges is the magnitude of electric dipole moment, denoted by small p, mod of vector small p or simply small p. SI unit of electric dipole moment will be coulomb meter, and R is the distance of that point from where we want to know the electric field intensity, from the midpoint of the line joining the two charges. You know that if minus q and plus q are formed electric dipole, then line joining the two charges is known as dipole axis, and the line passing through this dipole axis is called axial line, and the line passing through the center of this dipole axis and perpendicular to it is called equatorial line. If the point at which we want to calculate the total electric field intensity is situated at this perpendicular distance, suppose that this is P. P is that point at which we want to calculate total electric field intensity due to electric dipole. Then joining this point by both of the charges, we will get a triangle. Suppose that this triangle is A, B and C. You know that the length of the electric dipole is 12. So suppose that this point is V. So what is the distance AD? Obviously we can say it is L, and DC is also L. So total distance will be 12. Now we assume a test charge at point P. Suppose that a test charge is a positive charge, and a very small positive charge, which is used to know the existence of any external field. Suppose that plus Q naught is a test charge which is placed at point P. This is positive charge and plus Q is also positive charge. Then force between these positive charges will be repulsive in nature. So this positive test charge will move away from the charge plus Q. So the direction of electric field intensity due to positive charge will be away from this positive charge, like this, away from this positive charge. This is electric field intensity vector E1 due to positive charge. This is a straight line. And what is electric field intensity? You have studied that Coulomb's law between two charges is given by 1 upon 4 pi epsilon naught k q1. Here Q and Q naught. You have seen that a positive test charge Q naught is placed at point P. Here in place of Q1 Q, in place of Q2 Q naught, upon, suppose that this distance is R. This distance is R. So using Pythagoras theorem we can calculate the distance AB will be under root L square R square plus L square, under root R square plus L square. And AC also will be under root R square plus L square. So concept of electric field, F equal to 1 upon 4 pi epsilon naught k q naught upon R square, here R square plus L square under root whole of square, means 1 upon 4 pi epsilon naught k q naught upon R square plus L square. So electric field intensity is defined as the force acting on per unit charge, means F upon Q naught. Force acting per unit charge is called electric field intensity at point P. F upon Q naught. What will be the value of F upon Q naught? You can see F is equal to 1 upon 4 pi epsilon naught k q naught upon R square plus L square. So value of E will be 1 upon 4 pi epsilon naught k q upon R square plus L square. This electric field intensity is termed as E1, and similarly we can write E2, what will be the value of E2, and direction I will tell later. 1 upon 4 pi epsilon naught k q upon distance AB is also under root r square plus l square, then q upon r square plus l square. Here this electric field intensity E2 is due to negative charge, but negative sign is not placed here because of electric field intensity is a vector quantity. So in any vector quantity, negative sign will not be placed in the scalar form of that quantity. This is scalar form of that quantity, scalar form of electric field intensity. If we write vector form of electric field intensity, then we will put the negative sign like this. If we write vector E2, then we will put negative sign as well. 1 upon 4 pi epsilon naught k q upon r square l square. But here it is the scalar form or just only magnitude. E2 equal to 1 upon 4 pi epsilon naught q upon r square plus l square. Now what will be the direction of E2? Suppose that again plus q naught is test charge, it will move towards the negative charge because this force between negative and positive test charge will be attractive in nature. So direction of E2 will be towards negative charge E2. So resultant electric field intensity will be this. These are inclined electric field intensities E1 and E2, and this is the resultant electric field intensity vector E in along horizontal. So suppose that this angle is theta. If this angle is theta, then this angle will also be theta because these angles are alternate angles, and you can see these are equal sides, and angles in front of equal sides are also equal. So theta, this angle is theta, so this angle will also be theta, and this angle is theta, so this angle will also be theta because of these angles are corresponding angles. So total angle between vectors E1 and E2 is 2 theta. Angle between E1 and E2 equal to 2 theta. You can see. So using vector formula of vector addition, resultant electric field intensity vector E will be vector E1 plus vector E2 in vector form, and its magnitude is given by E equal to under root E1 square plus E2 square plus 2 E1 E2 2 E1 E2 cos phi. Suppose that cos phi, where phi is the angle between E1 and E2, and here phi is given 2 theta. So you can see E1 and E2 are equal in magnitude, so we can write E equal to, suppose that this is E dash and this E2 is also E dash, because these magnitudes are equal. So we can write E dash square plus E dash square plus 2 E dash multiplied by E dash means E dash square cos 2 theta. Cos 2 theta means E equal to under root, this will be 2 E dash square in bracket, after taking common 2 E dash square 1 plus cos 2 theta. You know that formulas of cos 2 theta in trigonometry, cos 2 theta equal to, first formula is cos square theta minus sin square theta, and second is 1 minus 2 sin square theta, and third is 2 cos square theta minus 1. If we use the third formula, then 1 will be cancelled out. So E equal to under root 2 E dash square to E dash square in bracket 1 plus 2 cos square theta, 2 cos square theta minus 1. So 1 and minus 1 will be cancelled out. So what will be the value of E? E will be 2 multiplied by 2, 4, and square root of 4, 2. 2 E dash square root of E dash square will be E dash, and cos square theta square root of cos square theta will be cos theta. So E equal to 2 times value of E dash, either the value of E1 or E2, 1 upon 4 pi epsilon naught k q upon r square plus l square multiplied by cos theta, value of cos theta from triangle ABD. From triangle ABD we can easily calculate from triangle ABD cos theta will be base upon hypotenuse, base will be L upon hypotenuse means root L square plus R square plus L square, means we can write R square plus L square whole power 1 by 2. Substituting the value of cos theta in this equation, L upon R square plus L square whole power 1 by 2. So it will be, you have studied that product of charge and distance between the two charges 2L, Q into 2L is known as electric dipole moment. So in place of 2QL we can write P, small p. So 1 upon 4 pi epsilon naught k P upon R square plus L square, after multiplying these brackets R square plus L square whole to the power 1 by 2 plus 1 means 3 by 2. 3 by 2 whole to the power 3 by 2. So this is formula for total electric field intensity due to electric dipole in equatorial position, equatorial line. And if we assume that distance between the two charges 2L is very small, then L will also be very small, and square of this distance will also be very small. So in compare of R square, L square can be neglected. L square is much less than R square, so L square can be neglected in compare of R square. So we can write E equal to 1 upon 4 pi epsilon naught K P upon R square whole to the power 3 by 2 means R cube. R cube. This is the formula. This is the required formula of electric field intensity due to electric dipole in equatorial position. You have already studied the formula for electric field intensity due to electric dipole in axial position, and in our next video we will discuss about the principle of superposition of electric charges. Till then, keep watching. Stay safe, stay home. Thank you.